In this video, I'm going to write script code to model the state of the game and draw the current game state. If you haven't read the blog post describing the reuse model code, now would be a good time to do that. There are links below. The game model will include the player state, which is just how many chips they have and which cards they have taken, and the non-player state, which includes the player order and current player, the shuffled deck of gift cards, the current card being bid on, and the number of chips already bid. The reuse scripts already model the list of players, the player order, and the current player, along with each player's table position and color. So I'll start by adding code to the game model for the deck of cards and the number of chips. Double-click on the game script to bring up Visual Studio. The deck of cards can be modeled as a list of integers since the card's value is its only feature. I don't need to separately store the current card being auctioned. I'll just assume that the top card on the deck is the one that is face up. For the player, I'll use a list of integers to represent the cards that they have taken and an integer number of chips they currently have. I'll also write the function to calculate the player's score, since I'm going to need that to display on the player user interface. The player's score is the number of chips that they have minus the value of the cards that they have taken, except that a sequence of cards only costs the value of the smallest card. So if the gap between cards is greater than 1, I'll include that card's value. For this function to work correctly, I need to make sure that the cards are sorted. I'll also want to draw the cards sorted, so I'll go ahead and resort the list whenever a new card is added. Next, I'll write code to initialize the game in the eInitialize event. For no thanks, eInitialize needs to pick a starting player, set the game state to play, make a gift deck with the cards 3 through 35, shuffle the deck, and remove 9 of the cards randomly. It also needs to give the players the correct number of chips based on how many players there are. The eInitialize event is added to the timeline by the main menu when the game is started. This event executes after eReset, which resets the model, and eAddPlayer, which adds the players. That is the whole game model. Now I'll write code to draw the game model to the user interface. First, I'm going to make a card GUI class that will draw a face-up card. I always add new script classes through the Unity editor. The card GUI class will contain the 3 text elements, center, upper left, and score line, and will have a draw function that takes the value of the card and a flag for whether or not to display the score text. This will allow the card GUI to draw both the card up for auction in the center and the cards that the player has taken. The game GUI script is responsible for drawing the non-player specific areas of the user interface. For no thanks, it will draw the number of cards left in the gift deck, the card on offer, and the number of chips played. This line of code is finding the text mesh behavior on a specifically named child of the chip. This saves adding another member to the behavior, which would need to be set in the editor, but it also uses a string literal that you then have to make sure not to change in the editor. I end up using these literal lookups more than I should, especially in larger games where there are a lot of UI elements being set by the script. I'll only show the chip icon with the number of chips played if chips have been added. The size of the deck is 1 less than the number of items in the list because the top item is the face-up card. If the gift deck is empty, I want to hide the face-up card instead of drawing it. The player user interface is the most complicated part of this game. It needs to add card and spacer objects to the horizontal layout of cards based on the cards the player takes during the game. To do that, I'll store the card and spacer prefabs along with the card container they'll be put in. The script also needs the total score and chip objects. I'll set the player area to the color of the player. The chipped object has two text mesh children, one for the number of chips displayed on the chip itself, and another for the score line. This code will set them both to the correct number of chips. The total score is available from the player class. The draw function is called by the event system when the player area needs to be redrawn because the player model has changed. However, the cards themselves may not have changed, so I'll only redraw the card area if there is a different number of cards than the last time the area was drawn. I'm doing this check because of the overhead of destroying and creating objects, but it probably doesn't really matter for this game. If the number of cards is different, I'll delete all the cards and spacers and recreate them. I'll add a spacer if there is a gap between two cards. I do this by instantiating the spacer prefab and adding it to the card container. Passing false for world position stays allows the container to size and position the spacer. I'll do the same thing for the card itself, and will use the instantiate function that sets the parent at the same time. I'll use the card GUI class to draw the value of the card. The score text should be drawn if this is the first card in a sequence. Finally, I'll add code to the player dialog script to draw the gift icon that indicates whose turn it is. The reuse code already draws the ribbon. The gift icon should be active if we are playing the game and the player that is represented by this dialog is the current player. Now I can return to Unity and link the script member variables to the UI elements. First, I'll double check that I use the correct name for the chip's count text mesh child. Add the UI elements and prefabs to the player GUI behavior. Then apply the change to the player area prefab. Next, add the player areas to the game GUI by locking the inspector and dragging in all the player areas. Then add the other user interface elements. I'm not able to add the drawn card because I need to add the card GUI behavior to the drawn card prefab. Add that behavior and drag in the text mesh elements. Apply that change to the drawn card prefab, then drag the card object into the game GUI. Finally, add the gift icon to the player dialog behavior and apply the change to the prefab. Now we can run the game and see that the user interface is being drawn to match the state of the game. That concludes the model and user interface code. In the next video, I'll create the events that will progress the game and add buttons with callbacks to allow the players to interact with the user interface.